Here's our clock face that we're going to be milling. Currently we're in design. I'm going to switch to manufacture. I'm going to come over and manage the tool library. I need to add some tools to this library. We'll be using 3 tools to mill this. I'm going to start with an engrave or chamfer mill. So this is in inches. It does have 2 flutes. However, it's carbide. The rest of this should be fine. Let's go to cutting data. The specs for this tool are that we can have a surface speed of, for 6061 aluminum, which is what we're using, up to 1,500 feet per minute for slotting, and up to 2,000 feet per minute for peripheral work. We're going to be doing both of those, so I just need to make sure that this stays under 1,500. Spindle RPM 5,000. Feed rate. Now, for aluminum, 6061 aluminum, we are specified 2 thousandths per tooth. So I need to adjust things to get us 2 thousandths per tooth. And then for plunging, we can have 7 thousandths per tooth. I'm sorry, 7 thousandths of an inch per revolution. So a little less yet. Close enough. And for the post processor, I will look up that information in a bit, but we will have a different number there for the post processor. We're going to add our next tool, which is a bullnose end mill. It's actually a chamfer nose end mill, but couldn't find that option. For the cutter, is there a chamfer? So here the edges are rounded over, so they'll wear fairly slowly. On the end mill we have, they have a little straight chamfer on the edge. This is a 3 flute. It is carbide. The diameter is 1/4 of an inch, and the rest of this is fine. We go to cutting data. Alright, for low silicon aluminum, which is what we're going to be cutting, we want a chip load per tooth of 2.4 thousandths of an inch. So we are fairly close there. We would like our surface feet per minute to be between 720 and 900, but our spindle maxes out around 5,000 RPM on this machine, so we can't approach those numbers. And this will put it in as tool number 2 for now, and we'll change that later. I'm going to go ahead and accept that. And now putting in our third tool. This is actually a roughing end mill, the one we just put in, which means it's designed to remove material fairly quickly. Our next end mill will be a finish end mill. It is a flat end mill. You go to the cutter. This is 4 flute. It's also carbide. The rest of this geometry is good enough. I'm going to go to cutting data. And for this, we want 1.8 thousandths. Per tooth. And we would like our surface speed to be between 490 and 660, but again, we can't get the spindle up fast enough on this machine to do that. Alright, this flat end mill, let's edit the tool. In the post processor, this is number 4. And accept that. Alright, this bullnose end mill, edit that tool. In the post processor, this is number 9. I'm going to accept that. I'm going to edit this engraving tool in the post processor. This is number 53. Accept that. Alright, these are the 3 tools we need. We've got them set up. Alright, now we need to set up the process. In fact, we will have 2 different setups. One for milling the back, which will happen first, and the other for milling the front. So I'm going to come up here to Setup, New Setup, and I'm going to rotate around to the back. I want the origin on a stock box point. I'm going to select that point now. I want it to be that point. This is centered on the stock, which is shown here partially see-through with the part inside. Alright, next let's define the stock. I want a fixed size box. It's going to be 6 inches in X, 6 inches in Y, and 0.25 inches in Z. Check to see if that's what we have. It is. And I'm going to click OK. See, I have setup 1, that's for milling the back. Now I want another setup. So new setup. This time, the stock box point I want is up here on the front. Something that's very important is that Y is pointing in this direction, X positive is pointing in this direction, and Z positive is up out of there. I'm going to go ahead and click OK on this, but let's go back and edit one just to make sure that that's what we have. Oh, no, it's not. We've got Z positive pointing down. So to fix this, I'm going to click here. Instead of model orientation, let's try the select X and Y axes. Here for the X-axis, I'm going to select that. It's correctly selected, but I want it flipped. Just by flipping the X-axis, I now have the correct orientation with Z pointing up and Y towards the 12 and X towards the 9. I'm going to click OK. I'm going to come back and edit setup 2. This is for milling the front of the clock face again. Orientation of the axes is correct. I'm on the center point, which I want. Let me check on the stock. From previous is what I want. Okay. Alright, I've selected setup 1. I'm going to go up to 2D and get a pocket. First thing I'm going to do is select a tool. The tool I want is number 9. Select that. Then I'm going to select this surface. Under heights, I'll leave it like this. Under passes, maximum step over, I'm going to reduce that slightly to 0.125. I don't want to leave stock, so I'll uncheck that. And under linking, I'm going to scroll down, and this ramping helix, to get down into the material, I'm going to change that to 10 degrees. And click OK. And it generates this toolpath. Next, I want to bore the hole for the shaft of the Clockworks to go through. I'm going to select bore. Tool number 9 is already selected. Here I'm going to select this face. On heights, I'm going to go a little bit below the hole bottom, so I'm going to put in minus 0.05 inches. Here under passes, I'm going to change this angle to 10 degrees. And under linking, everything can stay as it is. Click OK, and there's that toolpath. Alright, I'm going to put in a 2D chamfer. I'm going to select number 53, engrave chamfer tool, which is actually a mill drill. For the geometry, I'm going to select this contour, and this contour. And you want to make sure that this arrow is on the inside of this circle, this arrow is on the inside of this contour, and this arrow is on the outside of this contour. In heights, I'm going to leave everything alone. For the chamfer width, I'm going to put in 0.06 inches. And in linking, I'm going to leave everything alone. Click OK, and it adds that toolpath. Alright, now let's go to setup 2. I'm going to flip the clock face over. Now currently the mill drill or chamfer tool is in the machine, so I'll go ahead and start with that to reduce tool changes. Now I would like to chamfer this circle on this hole, but I can't because to mill the front face of the clock, I'm using this hole to secure the material. So there's a bolt in there, but I can chamfer the outside. So I'm going to go ahead and do that. And we have the chamfer tool in there. I'm going to select that circle. You can see that the arrow is on the inside, so I'm going to click the arrow to move it to the outside. I'm going to go with the same 0.06 inches for the chamfer and click OK. And now we have that tool path. Now this is the same tool that I'll use to engrave the numbers, so let's go ahead with that and click Engrave. We've got this tool, which is the one we want, and now I'll just select all these numbers. And click OK. There we have those tool paths. Alright, before you use a drill bit to drill a hole, you use a center drill to start the hole. A center drill is very short and rigid and won't wander. A drill bit, on the other hand, is long and slightly flexible and can wander and get the hole started crooked. The mill drill is also short and fairly rigid, and while not an ideal tool, is what we're going to use to start these tapped holes so that we can use a drill bit to drill them. So I'm going to go to drilling, drill. We have tool number 53 in there already. I'm going to select the hole faces, this one, and this one. And then under heights, I'm not going to the whole bottom. Here I am going to select the whole top, but put in minus 0.08 inches down from the whole top. And that puts in that tool path. Alright, it's time to get a new tool. I'm going to go back and get that roughing end mill and cut the clock face mostly out of the stock. So we're going to get a 2D contour. I'm going to select number 9. I'm going to select this lower circle. And I do want tabs. I'm going to change this to every 4 inches, so I have about 3 tabs. On the heights, instead of just the selected contours, I'm going to have the selected contours minus 0.05 again for the bottom height. For passes, I want multiple depths, and I'm going to go 0.0625 as the maximum. I do want stock to leave. 4 thousandths is fine. And on linking, we can leave things as they are. All right, here's our tool path for that, and you can see how that will cut the clock face out of the stock, leaving these tabs so things don't come apart. All right, that was with the roughing end mill. Now let's take that last 4/1000ths off with the finish end mill. I will get another 2D contour. Select tool number 4. I am again going to select this lower circle. I'm going to put in selected contours minus 0.05 as the bottom. For this, I don't want stock to leave. I don't want multiple depths. I'll click OK. All right, we will get around to drilling and tapping these holes, but first let's look back at setup 1, where we're milling the back of this. When these holes are drilled and tapped, there's the possibility of forming burrs on the back side. But we can come back while we have this chamfer tool and just barely peck into where these holes will be to reduce the likelihood of burrs. Now, if we just go straight to putting in a drilling operation, it will get rid of our tools because we haven't specified any drills as tools yet. But there's a way to trick it into doing what we want. I'm going to right-click on Chamfer 2 and click Edit. You can see that we've got this number 53 tool here. I'm going to click OK, and then I'm immediately going to go to Drill, and it puts in the number 53 tool. Next, I'm going to select these hole faces. And here, I'm going to change this to hole top. And put in minus 0.08. Just added in this last operation for setup 1. All right, back to setup 2, and time to drill the holes. Just kidding, we can't because we don't have the tools to do that yet. So let's add a couple more tools. Go up to Manage, Tool Library, and I am going to add a drill. For the cutter, this is inches, 2 flute, high-speed steel. This is a number 36 drill, so it has a diameter of 0.107 inches. It is 118 degrees. I'll leave the rest of that alone. It is good enough. Shaft and holder are good enough. Cutting data. Let's knock this 5,000 RPM down to 2,000 RPM. And I want to get the feed per revolution down to around 0.003. Where does that put us? Close enough. 6 inches per minute. Retract rate of 40 inches per minute is fine. Post processor, this is tool 70. Accept. Need another new tool. This is a tap right hand. We'll leave this 3 flutes high-speed steel. This has a major diameter of 0.138. The overall length and whatnot is fine. Jumping over to cutting data, the slowest we can go is 400 RPM, so that's what we're going to do. And then let's go ahead and do the math. But there's nowhere to put the math here. It must be back here. So we are using 632 screws. 6 is a number that refers to this diameter, and 32 means 32 threads per inch. So as you're counting up these, there are 32 of these exactly in 1 inch, which means that the thread pitch, the distance between 2 threads, is exactly 1 divided by 32, or 0.03125 inches. And we can accept this. And there are new tools, 70 and, oops, need to edit this one, 70 and 71. Accept. Close. All right, let's put in the drilling. It appears down here. We do not want tool number 4, we want tool 70. We'll select these 3 holes to the whole bottom. I'm going to make this go 50 thousandths deeper. I'm going to select deep drilling with full retract with a peck depth of 0.15 inches. 1.5. There we are. Okay. And there's that tool path. Next, let's go drill. We do not want tool 70, we want the tap, tool 71. We want the same geometry again. For the heights, I'm going to leave this I'm going to make this a little different. The tap we'll be using takes several threads before it works up to full diameter. And I want to make sure I have full threads at least halfway through this clock face. So I'm going to subtract full 1/10 of an inch from the whole bottom. And this is a tapping cycle. 0 dwell is fine. All right, let's go ahead and simulate these setups to see if it looks like what we want to have happening is happening. I'm going to right click on setup 1 and click simulate, and then click play. And I can adjust the speed here. There's the 1/4 inch end mill. Now we've switched over to the mill drill. Good, I'm happy with that. Exit simulation. I'm going to right click on Setup to simulate. Oh, exit simulation. Let me flip the part over so I can see what's going on a little better. Right click on Setup to simulate. Play. Alright, it's going around and getting that outside chamfer. Puts in the numbers. Starts the holes. Now we're on the roughing end mill. Taking multiple passes, leaving those tabs. Now the finish end mill. Cutting off the tabs. Drilling the holes. And tapping the holes. Looks good. Exit simulation. Now we will post-process each of the setups separately because they're two different fixtures. I'm going to right-click on Setup 1, select Post-Process. Now under the Post, you can see that I've selected Tormach Path Pilot. You may have to look in this folder to find that. I do not like to post to the Fusion team. I don't need to open in NC File Editor. You can select that if you like. Program name, program number, and file name. I would go ahead and give this a name. Something like this. Output folder. Pay attention to where this is going. You might just drop it on the desktop if you want to keep track of it. And see if I can get this on the screen. Post. It wants to know if I want to download Visual Studio to look at the code. I don't. And here is the code. You can see it will call out the different processes. Can right click on Setup To and do the same thing. Post process. Got the Tormach Path Pilot in there. And post.